Mates in SolidWorks keep structure perfectly lined and glued together, basically. So right here, I have a C channel and I have a bearing. So because I have some mates that keeps this bearing with the C channel, the bearing is able to move with the C channel and not stray off course. So take this example where I want to merge the C channel like this with the other C channel. Um, the way I can do that is with coincident mates. Coincident mates basically make the two faces that you select on the same plane. So for example, I'm gonna select this face and I'm gonna select this face, and basically it will make these two faces on the same plane like this. The second mate I would like to talk about is the concentric mate. So the definition of concentric is two of many circles having the same center point. So in this example, we have a flex wheel right here and a C channel right here. And you can see in the C channel library, or in the Vex Solidworks library, that the C channels have these circles around here instead of just being a full square. So this is due to the concentric add-on. So we can select this, which has a center point. You can see that comes off right here. And we're going to line the center point with this flex wheel. And we're going to control select this flex wheel, which also has a center point right here. It just disappeared. But basically, we can mate these two to share the exact same center point. So just click that, let it pop up, and you see right here the concentric mate. We'll click that, and right now the flex wheel and this hole in the C channel will have the exact same center point. And now the flex wheel will be able to rotate around the center point. Okay, so here we have our pretty common situation where we want to mount this bearing onto the C channel, kind of like this. Yep, just like that. Except it's offline and mates can make it online. So basically, to mount this bearing, we'll use two concentric mates and one coincident mate. The two concentric mates will be us clicking this inner circle right here, and this will have a middle point right here. And then we can also click the C channel circle right here to share the same middle point. And now the bearing and the C channel hole will share the same middle point. So as you can see here though, the bearing can still rotate like a joint, basically, because they're sharing the same middle point, but it can still rotate. So in order to make it fully still and fixed, we could use another concentric mate to align this hole with this hole right here. So we're gonna click this arc, which has a center point in the middle of the bearing, and we're gonna click this arc of the C channel, and it will make the bearing and the C channel share the same center point, which is around here. So now our bearing is actually it can't rotate and it's fully lined up. Except now you gotta look at 3D and the bearing can still move like this. So the way we can fix that is that we can click this face right here, which is basically the back of the bearing. We click that, and then we can click the C channel face right there, and we will coincide in it, and it will make it on the same plane, basically. So that face will converge with that face and merge with that face, yeah. So now the bearing and the C channel are, yeah, they're fixed. And you can see that SolidWorks even says the selected component is fully defined. It cannot be moved. So we successfully mounted this bearing onto the C channel. So in this situation, I just want to make these two C channels lined up so I can put some wheels into it and some gears in between it and, create a side of the chassis. So right now, the problem is that this C channel and this other C channel are not lined up perfectly, and this can move freely. So the way we can fix that is by using two concentric mates. So right now, we can see that when we want it lined up, all these holes, they line up with each other. So we can click this arc right here, which shares a middle point right here, and this arc right here, and we'll click the concentric mate to make them share the same middle point. And right there, you see these two arcs will be lined up now, and it actually kind of acts like a joint right now. You can rotate around it. It's a little confusing because I'm moving in 3D. Wait, let me get an angle. There you go. So right now, this will act as a joint, and it can move like that. So in order to actually make it, so in order to get it lined up with the other C channel, we just need to do another concentric mate to get it lined up. So we'll click one arc, and we'll click the other arc, and then we'll concentric that. And then now you can see that the C channels are actually lined up perfectly together. So right now I don't have a definite width of my chassis, and it can just kind of move like this. So the way we can have a definite width is by using another C channel. So structure C channel, and then pull another C channel, select a length of 5. So we're gonna have a 3 wide chassis in this example. So we can rotate this like this. It doesn't have to be exactly perfect, but just a rough estimate. So right now we have another C channel that is perpendicular to the other ones. So basically, we can use concentric mates to line up this middle point hole with the other middle point hole. So I'm going to click this arc and this arc, and we're going to concentric that. And right now, this C channel is lined up, and it moves with this. So now I will define width by using the 5 long C channel and concentric this with this, and now the width is defined. So now the C channel cannot move anymore because it is now at a set distance from the C channel. So in this situation, I want to put an omni wheel right here. So it will spin around this hole right here, and it'll just spin like this. So I will take an omni wheel from the library. Wheels, there you go. Let's just take an anti-static one. So we have a 3.25 inch omni wheel. It's rotated the wrong way. That's okay, because basically when you concentric mate, you don't need to be exact. Like the omni wheel doesn't need to be exactly lined up right now. So for example, I can just right click, just hold right click, hold right button, and then just drag upwards, and this omni wheel will just go upright. And it doesn't have to be exactly lined up to the hole, because the point of the concentric mate is to actually line it up itself. So I'm going to click this arc right here, and then click this arc right here, and concentric mate it. And now this omni wheel is actually lined up to the hole. So if I switch views to this one, this omni wheel is now rotating and around this hole right here, this middle point. The problem right now is that the omni wheel is kind of just floating in midair, and there's nothing really that's on. So why don't we add a screw right now? So this screw is basically what the omni wheel is going to rotate around. I'm going to pull out a 2.5 inch screw. I'm just going to rotate it pretty casually. The rotation doesn't have to be exact, but it's just somewhat close, I guess. So we're going to click this arc, which goes fully around the screw. And we're going to share the same center point with this C channel piece right here. And click the concentric. And now the screw is actually in the middle of the C channel. Alright, so you can see right here that this high strength does not spin around the screw very well. So we need an adapter to basically make it spin freely on the screw. So we'll just move this omni wheel outside for a second, and we're gonna bring in a plastic shaft insert. So this thing right here, this will turn the high strength into a screw hole, basically. So we're gonna click this arc right here, click the other arc right here, and concentric it. So now the insert is perfectly in the middle of the omni wheel. And in order to basically stop this from sliding and let it just plant onto the omni wheel, we select this face right here and this face right here, and we're gonna coincide in it, and it's basically just gonna merge them together. So now they are together. So I'll do it really quick another time. So plastic shaft insert, I'm gonna rotate a little bit just to give it a head start. Arc, arc, concentric, coincident, these two faces, and there we go. That's it. Now we have plastic shaft inserts on our omni wheel, and now it can spin well on the screw. So right now I want to attach the 62 gear to the omni wheel right here. So I can do that by basically centering the gear to the omni wheel. So I'm going to press this arc, and then I'm going to press this arc right here and concentric it, and now the gear is fully centered onto the omni wheel. But there's a problem still that the gear, there's not good spacing right now, and it can move like this. So in order to fix that, we need to add some spacers. Alright, so the spacers I'm going to use are these 3/8 inch spacers right here. So I'm going to put 2 because I will attach the gear with 2 screws. So right now I'm going to select this curve right here and one of the curves on the gears. So this one. And I'm going to concentric it. And it's automatically going to rotate the spacer to fit the gear, basically. So right now I'm going to click this face and click the face on the gear and coincide in it. And that's going to make the spacer's face and the gear's face line up. So I'm going to do that with the other spacer. This, that. There you go. Now it's lined up. Click that face. Click this face. And now it's lined up. So basically right now our gear is able to rotate freely. So we can lock this rotation by just lining up a spacer with one of the holes by using the concentric. So now it's just lined up. It can't rotate. It rotates with the wheel actually now. So our gear can still move like that. So we just select the face and then select the face, the surface face of the other of the omni wheel, and then coincide it. And now our gear is actually with our omni wheel now. And yeah, just like that. So right now, basically just move freely on the axle and it can grind on the C channels. So we'll add a couple spacers. So I'm open up the spacer menu and maybe I'll go for a 1/2 inch spacer. I'm going to select this arc and the circle basically and concentric that. And now we have a spacer on the screw. I'm going to select this face and that face and coincide in it. So these faces basically merge together, and now the spacer is stuck to this face. And just one more spacer. So let's just add a 1/4 inch one. We're going to do the same thing. There you go, select that, and then put it on the screw, and then we're going to select this face, and we're going to select this face right here, and coincide it. And now we have spacing for our for our wheel, and now it won't grind on the C channels. Oh, but it still moves, so we just have to coincide in it, and then put on the spacer. Okay, now it won't move. So there are some tricky gears that are hard to actually line up with these holes right here. So for example, the 24 tooth gear. So if we go to, where is it? X parts, there you go. Motion, high strength, there you go. 24 tooth gear. So there's no actually circle that we can use to line up with the holes, with other circles basically. So in order to actually use the 24-tooth gear, we have to add inserts. So for example, I'm adding this plastic shaft insert right here, and we'll just rotate it like that. So we can't use concentric mates right here. We have to use coincident ones. So we select one of the face of the insert, and then select inside of the gear, and then we can do a coincident mate. And right now it's just like this, and then we can do it on another side like this, and now we're actually in the middle of the gear. And then finally we do a coincident mate right to the end of the gear right there. Now we have a fully defined insert inside the gear, even if we didn't do concentric at all. And now with this plastic insert inside, we can actually line it out with these holes now. So we can click one of the arcs, on the C channel, and yeah, now our gear is lined up to the C channel and can rotate around it. One quick thing about shafts real quick, so I have a metal shaft right here. They actually have little arcs. So you can see right here, I can click this little arc right here, and that's really good because you can center it in another circle on the C channel, and the shaft will actually be centered inside the C channel, which is very easy. And now finally adding a motor. So we'll just go to Vex Parts, Electronics, V5, Motor, and right here, if it will load. There you go. Big chunky boy. So we just have to line it up with a couple concentric mates, and we're good. So the motors have actually arcs right here that you can click on, and then you can line it out with the C channel circles. There we go. And then right now this motor can pivot because it's only on one concentric mate. So just do it again on the other one. And now the motor's lined up like this. Except it can still move. So just another mate, coincident this time. And now it's fully defined. Cannot move. That's how you attach the motor. Alright, so the second part of this video is going to be about polycarbonate catting and designing polycarbonates. So to do that, we go to File, New, and instead of assembly like this is, it's going to be New Part. So we're going to go, okay, New Part. And then we're going to, in the top left under the Sketch tab right here, we're going to click Sketch, and top plane is good. So right now we just have an empty sketch and we want something. So let's just create a rectangle right here. So there's going to be a rectangle option, and there you go. There's a rectangle. So let's just say that we want this rectangle to be 3 inches in width and 2 inches in height. So the way we would do that is with Smart Dimension. So in the top left right here, we have Smart Dimension. We'll click one of the edges and the other edge. And you know, right now, double click, and you know how it says 6 inches right now? We're going to type in the 3 inches that we want. So there you go. Now it's 3 inches long. And then we're going to go top and bottom, double click, and see right now it says 1.2 whatever. We're going to change it to 2 inches. And now we have a 3x2 sketch. Alright, so we have this rectangle right now, and we want to add a couple of screw holes in it. So in the top left also, there's a circle option. Click that, and just create a circle. So don't quote me on this, but I think the radius of a circle for a screw hole is 0.95, but I could be wrong. Like, oh, no. Sorry. 0.095. There you go. There you go. I think so, but I'm not sure. But anyways, we'll just work with that for now. So 0.095 radius. We're just going to drag the screw around here. So let's say we want the hole to be half an inch from the left edge and half an inch from the bottom. So we would go smart dimension. We're going to click the middle of the middle point of the circle. And then we're going to click this edge right here. And it's going to pop up a menu, or sorry, like a menu. And then we're going to put it 0.5 inches. There you go. So now it's 0.5 inches from the edge. And we'll do it again with this edge. And 0.5. There you go. So now our circle is 0.5 inches from each edge. So that's how you add a screw hole. So let's say I'm creating a polycarbonate sled for over under and getting over the bar. So we select this sketch fillet right here, which will round this bottom right corner so we can actually go over the bar with our sleds. So we can click that, and then we're gonna select the vertice that we will that will be rounded off, and we'll click that. And right now we have a preview of what the arc will actually look like. So let's just say, yeah, I like it. I'm gonna click yes. And now we actually have an arc that has a radius of 1.5. So let's say I'm done with my sketch and I want to turn it into actual 3D polycarbonate sheet. So we can go to features on the top left and extruded boss/base. So we click that, and you can see that we gain some height to our sketch, and yeah, it's basically 3D now. You want to make sure that these screw holes are hollow, basically, so you can see that this is hollow, because sometimes it's like this, right? And we want the screw holes to actually be hollow, so we can just click it again. There you go. Okay, there you go. So now we have the screw hole hollow, and so we can actually determine the height of it right here. I think polycarbonate is like 0.0625 inches, like that. And we can just click check mark. So now we have a part. All right, so we're back in our assembly, and we want to put our goofy sled onto our C channel. So we're gonna open I have a Lexan folder, and we're gonna pull out goofy sled, and this is our Lexan. So we can rotate it, make it parallel with the C channel, and then just attach it on. So I have a circle right here, so I can actually do concentric with one of the C channel holes, but yeah. And that's our sled.